The Atwood machine. Here's my rough sketch that I did in Word. It's a pulley system as seen below. Mass M2 makes it easier for a person or a motor to lift mass M1. In fact, M2 is often called a counterweight if you're in the industry. Oh, we got a thought puzzle. We get to vote. It says this. Equal masses are placed on both sides of the Atwood machine, and one mass is lifted higher. Sorry for those of you who are at home on YouTube, but for those of you that are here, I think we're talking about this. So here's equal masses, and one mass is going to be lifted higher. When I let go of this higher mass, what happens? A, nothing. The system remains at rest. B, the higher mass falls because of gravity. C, the higher mass goes higher. And again, this is not an accurate simulation. You have to imagine that this right here in the pulley is frictionless, so nothing's being slowed down. So here's our situation. We start out with two identical masses. We raise one to here, and we let it go. What's going to happen? A, the system remains at rest. Nothing happens. B, the higher mass falls. Or C, the higher mass goes higher. Once again, oh, Riley, we're going to vote. Once again, how high you hold your hand up is how sure you are of the answer. Who says, Mr. Dewick, this is easy. Nothing's going to happen. The system's going to remain at rest. A. I got one. I got two. I got two. Psst, psst, go. Thank you. Who says the higher mass is going to fall because gravity? You started to. I started, yeah, and then you looked around. No? Okay, I got two. Come on, have some conviction. Were you part of that too or not? 3. Who says the higher mass goes higher? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. I'm not going to answer your question. Instead, we're going to figure it out together. How are we going to figure it out? You know what this might be a good job for? I'm going to zoom in on this one here, this picture here. Let's do the free body diagram for this picture here. Let's start on the left. What are the forces acting on it? Everybody, get the obvious one? Good. mg. Now, normally I would say, is there more than one mass? And you would say yes. But did it say both masses are identical? Then I'm just going to use m for both of them. I don't need to call one m1 and m2. What else? Yes, good. Tension. Is there a normal force? Is it sitting on a surface? No normal force. Is there friction? No, this is a massless, frictionless pulley. I know, to make the math nice. I think that's it. So over here, what are the forces acting on it? Get the obvious one. Good. Tension. Now, most of you picked answer C, which I guess you're saying that it's going to accelerate that way. I guess you're saying that's the winner. Let's write an equation with that being the winner. So what's going to happen? Anything that ends up pointing down once it gets to the right-hand side, we'll call that winner plus. Anything that ends up pointing up, it's going to be loser. Sorry, I didn't mean that. You minus. So let's write our equation. So we have winner minus loser. Now, you might be tempted because this tension is pointing up to say it's also a loser. But if you follow it, follow it. I think when it curls around to this side, it ends up pointing down. It's a winner plus. This mg here, you might be tempted to call it a winner because it's pointing down. But if you follow it, when it curls around and gets to this side, I think it ends up pointing up, Sarah, in the loser direction. So I think it's going to be a loser minus. And that's going to be M all A. Because there's more than one mass. Oh, why am I stretching? Oh, I love it when we lose tension. That's so relaxing. Ah! Why am I scared? Why? If everything cancels, what number is left behind? Okay, we have this. 0 equals M all A. If you multiply two numbers together and you get 0 as an answer, Declan.
One of them has to be 0.
In fact, you learn that in your quadratic unit in math. It's called the zero principle. One of them has to be 0. Is the mass 0? No. Declan. Therefore, A equals 0. So what's the correct answer? A, B, or C? A is the correct answer. Which two of you picked? Well done. Oh, it says, explain. You know what? If you did that, I would be thrilled. I would say, you did a beautiful proof. You did it algebraically. I can't argue with that at all. It must stay at rest. That's actually really useful. How many of you have ever been on an elevator before? Okay? What you don't realize is every elevator has a hidden counterweight that's the same mass as an empty car. So the elevator motor is only having to lift the people, the passengers, the cargo up. And then once you get off, once the elevator car is empty, the motor doesn't have to expend any energy to hold that car at that floor. It's all balanced. It's going to remain at rest. Oh, of course, in real life, the motor's pulley does have some friction, and the cables do have some mass. So I'm fibbing a little bit. The motor has to expend a little bit of energy, but nowhere near as much as we would without that counterweight. It's a really clever system. I like example 2. I like example 2. Example 2 is in this. There's going to be an Atwood machine on your test. And you're going to see this is actually a multi-step question. I usually make these worth 5 or even 7 marks. In Physics 12, every written question is worth 7 marks. Why? Because that's what it was on the old Physics 12 provincial. It's how I learned how to grade. But really what it means in Physics 12 is you're not going to have a plug and chug written question. They're going to be multi-step. And we're building there. We've come a long way from the beginning of the year. Here is an example of a nice multi-step question. It says, if M1 is 1.2 kilograms and M2 is 3.8 kilograms, you can draw them in if you want to. I'm just going to remember that they're there. Write force equations. What it really means is do a free body diagram. So Josh, you ready? Okay, giddy up. M2, what are the forces acting on it? Get the obvious one. And since they called the one on the left M2, I'll follow their notation. I'll call that one M2G. What else? Yep. What about the... Oh, anything else? Or no. No. What about the mass on the right? M1G. Attention. Do you remember at the beginning of this lesson I said I hope you don't learn anything? I'm hoping you're kind of really just confirming but not learning stuff. Which way is this accelerating? So here's the only part that hopefully is kind of Captain Obvious. Josh, which mass is heavier? What does the question say? M1 is heavier? So let's be very careful because that's a sloppy mistake to make on a test. Read the question. Which mass is heavier? How do you know? Because they said it was what? Now, a lot of people look at the diagram and they're like, well, M2 must be smaller, lighter, because it's, hey, maybe this is lead and this is wood. Look at the numbers, please. Which mass is heavier? Which mass is going to accelerate down? For M2. In other words, I'll add one more thing to my free body diagram. Off to the left, I'll put A with an arrow to let myself know that's the winning direction. What's B want me to find, Josh? I'm going to write an equation for everything to find the acceleration of everything. That should sound familiar. What's C want me to find? I'll write an individual force to find an individual mass to find an individual force, which I get hopefully sounds familiar. A says write force equations. What I really mean is who's winning? Yep. Say it. M2 is not a force. Thank you. I got to be fussy because every once in a while kids forget the G's. That's silly. So for part A, let's put a little part A. I agree. And what you've just decided, Josh, is anything that ends up pointing down, once it gets to the left side, winner plus. Anything that ends up pointing up, once it gets to the left side, loser minus. Give me my equation. I love how you rattled that off almost bored. That was the goal I was trying to get you to, where you just, yeah, this makes sense. Oh, equals. Yep. Do we get a little spa treatment relaxation? Stretch your arm. Oh, love it when tension vanishes. How do I find A? Declan's theorem. Hopefully, again, you're not learning anything new. A is going to be M2G minus M1G all over M1 plus M2. In our notes, let's plug in the numbers. In your homework, if you felt bold and you wanted to go straight to your calculator now, go ahead. On a test, show me your numbers. That way, if you make a calculator mistake, I can still give you everything but a half mark, right? Josh, what's M2? G, 9.8. Not negative. We took care of that with our winner minus loser stick. Minus 1.2 times 9.8 all over 1.2 plus 3.8.
Do that one in your head, Mr. Divick.
Maybe. Yeah, I can factor out a 9.8, 3.8, 2.8, 2.6 times 9. No, I'm going to give up. All of you should try typing that into your calculator because this is the level of difficulty we're going to need to be able to handle. Built-in error check. I know if I cut the rope, the maximum acceleration is 9.8, so I better get an answer less than 9.8. 5.10 if we go to 3 sig figs. Is that right? Meters per second squared. Great job, Josh. Awesome. Oh, you know what? Josh, I'm going to put a little part B there. Solve for acceleration. There I did. I mean, I'd figure it out as long as you put a box around the answer. I'd spot it. Cool. Riley, what's C want me to find?
Tension.
To find an individual force, I look at an individual what? Individual what? Mass. So, Riley, pick a mass. Okay. I probably would have chosen M1 as well. Why? Tension is winning, and it will be ever so slightly easier to get the T by itself. But if you picked M2, you'd be fine. And I've taught you to do so much of the math in your head that I can't even really say it's more work. So, which mass did you say, Riley?
M1.
Which way is M1 accelerating? Who's winning? Who's losing? Which one? There's 2 in the question.
M1G.
What's that going to equal? M1A. All right here. Or you could have gone M2G minus tension equals M2A. And to get the T by itself there, you would swappy dance. That would work. But here, Riley cleverly picked M1. How would I get the T by itself? How will I move that M1G over?
Plus it.
Yeah. How come? How do you know? Because there's a minus sign. So this is not swappy dance. This is just, I guess, tension is going to be M1A plus M1G. It's going to be M1, 1.2. A, I'm going to write 5.10. All of you are going to use your answer button. Yes, yes, yes. Plus 1.2 times 9.8. What do you get? Riley, what'd you get? Oh, you're still typing? Okay. 17.9? 17.9? Is that all right? By the way, if you really look at this, I mean, 1, 2, 3, 4, 5, 6. Yeah, this is 7 steps. So I often will make this worth 5 marks or something. Yeah. Quick look at money. Calculator error? Okay, let me come look. Pause the video for a second. Example 3. I like example 3. Oh, you know what? This is an Atwood machine. It's wanting me to find the acceleration and the chord tension. Here's what we're going to do. I'm going to shut up. Try this on your own. I'm going to just slowly write up here. If you get stuck, look up, but I'm not going to give you any instructions. If you can handle an Atwood machine, that you're going to get 5 out of 5 or maybe 7 out of 7 on a written question on the test. I can't call it free marks because you got to know what you're doing, but hopefully it's guaranteed marks. So try this one on your own. I might be wrong. Sorry? You should get the same answer, though. Am I wrong? Did I make a typo? I might be wrong. Oh, geez, I picked the wrong winner. How did I do that? Well, that was dumb of me. I'm totally wrong. Wow, Dewick. Got the acceleration right. Oh, now I got to go back and get that. I want my answer button back, Mr. Dewick. Sorry, YouTube. Let's try that again. I should have used M1. I should have gone tension minus M1G equals M1A, and then tension equals M1A plus M1G. And then I can go tension equals M1, which is 3.5 times answer button, plus 3.5 times 9.8. Wow, Dewick. 3.5 times answer button plus 3.5 times 9.8. Do you get 42.5? Is that better? Wow. I wish I'd done that on purpose. That would have been a good object lesson. But no, that was just me being sloppy. I'm going to leave it on YouTube. And then I'm going to put my phone away. I'm going to put my phone away. Thank you. Put your pencils down, look up. There's going to be an Atwood machine on your test. It's also going to be one of these. Example 5. Ooh. Joanna, what's example 5 want me to find? Read carefully. This is what I call a missing mass question. It's this question, but in reverse. Instead of me giving you both masses and saying find the acceleration, find the tension, I'm going to give you one mass and either the acceleration or the tension, find the missing mass to make this work. We're kind of going to do everything in reverse. So what does this want us to find? See it, Bryce? Missing mass. Okay. What's our strategy? Still going to be a free body diagram, but because I'm missing a mass, I'm going to write a free body diagram for the mass, Joanna, that I know. Which mass do I know? Let's write a free body diagram for M1. What are the forces acting on it? Get the obvious one. What else? I have to tell you one piece of information in this question. I have to tell you which way we're accelerating. If I don't tell you that, you can't solve this. Which way is M1 accelerating? Let's put a little A right there so we know. I'm not going winner minus loser equals M all A because I don't know M all. I got a missing mass. So again, I'll start with the individual mass that I do know. Who's winning? Who's losing? Equals M1A, right? Now, why did I do that? For me to find the second mass, I need both tension and acceleration. They gave me tension, but I can also find acceleration for mass 1, which is acceleration for mass 2. Or they could have given me the acceleration for mass 1. I would find tension because I need tension and acceleration to find the mystery mass. So in this case, I'm going to find the acceleration. A is going to be 56.5 minus 3.2 times 9.8 divided by 3.2. And I get, do you get 7.85625? I'm going to carry as many sig figs as I can because this is not what they wanted me to find. They want me to find mystery mass M2. So 7.85625. Casey, are we done? No. What do they ask us to find? Mass 2. We ignored it because we said we need both acceleration and tension to find mass 2. I can find those from mass 1. Now, let's go to mass 2. Casey, what are the forces acting on mass 2? Get the obvious one. Good. M2G. What else? Yep. Which way is M2 accelerating? Down. Which way is the winning direction? Down. Who's winning? M2G. Who's losing? Tension. What's that equal? M2A. Madison, what are they asking me to find? Yeah. Can I? Do I know G? Yeah. Do I know tension? They told me 56.5. Do I know A? Yeah. The only thing I don't know is M2, so I can solve this. Why is this equation tough? Casey, how many M2s do I have? How many would I prefer? You know what? Let's get all the M2s to the same side. I'm going to swappy dance. I'm going to plus the tension to here minus the M2A to here. Sadie, how many M2s do I have? How many would I prefer? You know what'd be really cool, everybody? And by the way, this is one of the more useful skills I'll give you this year. It would be really cool if there was a Math 9 operation that I could pull out of my back pocket, yes, from Math 9, and somehow change this from 2 M2s into 1. There is. For Candy, does anybody know what we can do here to change this from 2 M2s into 1? They aren't like terms. That's a good thought. Gather like terms. They would be like terms if this was an M2G and this was an M2G. But you're getting close-ish. Finley.
Oh, factor up.
Finley. What does, you learned this in grade 9, what does GCF stand for? Now you were used to doing it with X's, but is there an M2 in everything on the left? I can write this as M2 bracket G minus A. Casey, how many M2s do I have now? How many would I prefer? 1. Ha ha! I need to get it by itself. I need to move the bracket over. What's the bracket doing to the M2? Adding, subtracting, multiplying? So how will I move the bracket over? Well done. M2 is going to be tension divided by G minus A. Don't try and memorize that. Sometimes it will be tension divided by G plus A. Sometimes it will look a bit different. Like, don't say, this is always the equation. I've showed you how to derive it. I've scrolled down, Casey. What was tension? It was 50 something something something. It must say up there somewhere. I agree. And then G 9.8. And this is why I wrote down all of A, 7.85625. What is my answer button? Brackets around the bottom. I don't think I need brackets around the top. How big is mystery mass M2? No. Oh, I made a typo. That's what you're saying. Rats. Now I got to type out this whole thing. Mr. Dweck. 7.85625. Close off the bottom. You get that 29.1? Units. It's a mass. I'm going to pause here. I'll start tomorrow doing another missing mass question, example 6, then we're done. But I'm going to give you some homework to practice. So, number 1 is an Atwood machine. If you get number 1 right, you can skip number 2. Because number 2, it's the same question, I just changed the numbers. Okay. Number 3, you should be able to do in your head if you're really paying attention. I skipped 4, 5, and 6. Number 7 is a missing mass question. So is number 8. I've only done one of those with you, and they're a bit tricky. Number 9 is also pretty tricky. So 7, 8, 9 are advanced, and really you'll have some time to work on that tomorrow. But as far as I'm concerned, you can handle number 1. If you get it right, great. Otherwise, 2 is another Atwood machine. 3, and also a lot of you have homework from the previous lessons. We're basically done the unit. I'll do one more missing mass question for practice with you tomorrow. I will give you a take-home quiz tomorrow, and then we'll probably have one more take-home quiz and a study guide. Okay.